Good day, everyone. We are Group 6, and today, here is our midterm performance task titled Optimization of Garden Fencing. Maximizing planting area with 420 meters of fencing. But first, here is our goal. Our goal is to maximize the rectangular garden area using derivatives. Our role is that we are landscape architects and gardeners. The audience here is we have a budget consortium owner. And our situation is that we have a garden with three sides fenced with one side against a barn or a house. Next, our given for group 6 is that we are given 420 meters of fencing. So our mathematical model here is that let L or the length be the opposite of the house and the W be the width or the side perpendicular to the house. So we have L plus 2W is equal to 420. We only have one L or one length because the other one is the house or the barn. So we have to transpose. So L is equal to 420 minus 2W. Next, we have to optimize for our area. The area for a rectangle is length times width. Our length earlier is 420 minus 2W, so we only have to plot that times W. And we have to expand this for our equation. So 420 times W is 420W minus 2W times W is basically 2W squared. Since now we have our expanded form, we will now find our first derivative. So A prime W is equal to 420W minus 2W squared, both of which are constant multiple rule. They have a constant, a variable, and an exponent. So 420 times 1 is 420. W raised to 0 is basically 1. So 420 times 1 is 420. Minus 2 times 2 is 4. The exponent of W is 2 minus 1. So that is W raised to 1. That is still 1. So for W. Next, we have to find our critical points. So 420 minus 4W is equal to 0. By equating to 0, we will divide both sides by 4. So our width or W is 105. Our corresponding length is that L is equal to 420 minus 2 times 105, the equation earlier, so our answer is 210. Next, we are going to find our second derivative. Again, our A prime is 420 minus 4W. So we have to derive it again. So 420 is constant rule. So basically, any constant with no variable is basically 0. Minus 4W. That is constant multiple rule. We have a constant right there, which is 4. Or negative 4 rather. So, negative 4 times 1 is negative 4. W raised to 1 minus 1 is 0. So that still leaves us negative 4. To summarize, here's our final dimensions. Our width is 105 meters and length is 210 meters. So the final area again, our formula is length times width. So area is equal to 210 times 105. That gives us area is equal to 22,050 square meters. Now here's our Desmos graph. The function a W is equal to 420W minus 2W squared models how garden area changes with width. Its peak is at W is equal to 105 on the X right there. Shows the maximum area is at 22,050 meter squared. And here's our Minecraft representation. So we have our width, length, and our maximum area above. So 210 plus 105 times 2 is basically 210. So that gives us 420 meters of fencing, showing we have the right equation. To conclude, with 420 meters of fencing, the largest possible garden area is 22,050 meters squared, achieved with dimensions of 210 meters by 105 meters. By maximizing the area, we also save wasting material and made the most efficient use of space. So this project shows how calculus is not just numbers. It helps us solve real-world problems in design, efficiency, and planning. Again, this is Group 6, and thank you so much for listening and God bless. Hope you've learned something. Thank you.